Hey, what's up, students? So I wanted to go over going from exponential form to radical form one more time. I just didn't like the video I had made earlier, so I'm kind of redoing the video. I'm pulling from the same handout. I just didn't want to waste another copy, so I just kind of rewrote the problems on a piece of paper here. So these are the same problems on the handout. Just don't freak out because it doesn't look the same, okay? So just chill. So exponential form, again, this is the form where it's functional. This is what you put in a calculator if you actually had to do a fractioned exponent. Radical form is just basically there to look pretty, okay? So nice little radical sign, everything nice and neat. Here's what I think. So this denominator, if you have an exponent fraction, okay, the denominator loops all the way back around and it comes out and it goes outside of the radical sign, okay? So when you have more than just a simple fraction, you'll see more of these examples later, but that's kind of my idea. So the big thing here is if you're on the bottom here, it means you're outside and on the top over here. So these are actually a lot easier than it looks, all right? So let's go ahead and write these exponential ones in radical. Now this first one here is a 12a to the 2/3. 12 doesn't have any exponents, so it basically just stays 12. Okay, so 12 stays put. But the a has a 2/3. So again, the 3 is going to loop out and go on top of the radical sign, and then the 2 is going to stick to the a. So the numerator always sticks. The denominator is what gets yanked out of there. Okay, so you're just shifting things around. So apparently some people think this looks prettier than this. I really don't have a preference. I think they both are not very fun to look at. But hey, you know what? Who cares? Next one. 64a to the 4/5. Now you're really not going to like me here on this one. You have to treat it like a frying pan, okay? So 4/5 is going to multiply this, and 4/5 is going to multiply that. So that means we have a to the 4/5, and then we have a 64 to the 4/5. Now you're really not going to like me here. Okay, 64 actually does not have a fifth root. So what you need to do is you actually need to look through your little sheet that we made, your little matrix that you filled out, and find a number that does have a fifth root and see if that number goes into 64. Luckily, I'm going to do the work for you here. 64 can be broken down into 32 times 2. Okay, so 2 is going to get the 4/5 exponent, and 32 is going to get the 4/5 exponent, 4/5. So this actually does have a fifth root. Now, if you don't have a fifth root, that means you can't actually do any of these moves. But if you do have a fifth root, that means you can be simplified, okay? 32 to the 4/5 root, I believe, turns it into a 16. I can also double check with my calculator, okay? Or I can even use my chart. I think it turns all the way down into 2. But then if you take 2 to the 4th power, change it back into 16. Here you go. You're probably confused what I'm talking about. It'll make more sense the more of these you do. Let's see here. See, I need to get rid of that extra exponent. Go away. I don't want you. Okay. Hey, look at that. It turns to 16. So 32 has a root, and that is a fifth root, and that's a fourth. Sorry. 32 has a 4/5 root, and that number is 16. 2 does not. And A, you've got no idea what it is. So here's kind of my little trick here, friends. If you don't have a root, if you can't turn yourself into a regular number, then you need to stay inside the frying pan. Okay, so you're like, what are you talking about? I'll show you. Okay, so the 2 and the A have to stay. Okay, they can't get 4/5 rooted. 4/5 rooted. I can't, my lisp is killing me here, okay? So watch this. So follow the same moves, all right? So just like I did here, just like the 2/3, if I were to rewrite as a radical, I got to go radical sign. The 2 and the a stay inside the frying pan. And then see here, so the bottom number flips all the way out, and then the 4 stays sticking to the 2 and the a in brackets. So again, we are probably going to steer clear from many of these. I really don't want to do a lot of these types. I want to do the ones that work out nice. Okay, but if they do come up, I'll kind of help you along, but we're probably going to stick to the ones that actually have nice roots, okay? So speaking of nice ones, here's the got it questions. So here we go. This one's just a rewrite. Pretty simple stuff. Radical sign A, the 6 gets yanked out, the 5 sticks. Again, the denominator gets pulled out and it gets attached to the top of the radical sign. The numerator stays. Okay, here we go. Next one. This is very similar. Sorry about that. They made an announcement. I got interrupted. So here we go. Back at it. Here we go. All right. So the 5 doesn't have any exponents, so it stays a regular 5. Okay. This one's got all the noise, so I'm going to make a radical sign. 3 gets yanked out, X stays, and then you could write a 1 in there, but it's pointless. You don't need it. There you go. Leave it like that. Okay, leave it like that. And then gross. Here we go. We have another nasty one. So I'm going to help myself out a little bit. I'm going to give myself a little bit of a landing strip here. So I'm going to go square root, and then radical, and a frying pan. So whatever doesn't make it has got to stay, and whatever's going to make it out, I'm going to write right here. So you're probably like, what are you talking about, make it out? You'll see here in a little bit. So I have a feeling that I'm probably going to have a y in there. There's going to be a number that doesn't have a third root, and it's not going to get 2/3 rooted. I'm probably going to have a 2 here, and I'm probably going to have a 3 here. So I just got to figure out what number goes here, what number goes here. So let's break out 54 into 2 pieces. Okay, 54. I think that can be broken down into 27 times 2. So I'm getting a little bit ahead of myself. What's going on here, Mr. K? Well, I'm doing my frying pan. This is going to stick to you. This is going to stick to you. So now I got to break down 54 into something that actually has a third root. 27 does have a third root. I think that number is 3. So the third root of 27 is 3, but I need 2 of them. I need 2 of the 3 roots. So if the third root is 3 and I need 2 of them, technically I need to go 3 squared, which is 9. So 9 makes it out. 2 does not. Again, those are very, very hard questions. I totally agree. They're very, very tricky. We can go over them a few more times. I could really, really try to break it down for you. But exponential form and radical form is really some higher end stuff. It's really, really surgical number manipulation. But hey, if I can do it, I'm pretty sure you can do it too, okay? We got this, friends. Okay, goodbye.